Hello everyone, in this video I am going to explain you about shear force and bending moment in strength of materials. So in beams, uh, generally we know that beam is a horizontal member. In that beams the shear force and bending moment will occur. So shear force is nothing but algebraic sum of forces acting on either left hand side or right hand side of the section. If suppose this is a beam, okay, it is supported simply. If the load occurs at the center and the shear force will occur, suppose if suppose this is a brick, consider this is a brick which is in a beam shape, I mean rectangular shape. If I hit this brick by using my hand, it will break like this. Okay, so the shear force will occur in this manner. That is nothing but algebraic sum of forces either acting on left hand side or right hand side of the section. Okay, this is shear force. Next, when it comes to the bending moment, while applying my hand on this brick, the algebraic sum of moments, forces acting on the left hand side and right hand side of the section, usually the bending moment will occur like this. Okay, like that. In buildings also, suppose this is a beam, slab load is acting on this, so various forces acting on the beam, then the shear force and bending moment will occur. So that's why we civil engineers are studying about these shear force and bending moment, and this is a very important topic in strength of materials. So for that purpose we have to remember this sign conversion for shear force. If the section is, if suppose I told that it will fails like this, if it fails here, the load is I applied the load here and it will fails like this. This is our section. Okay, so for this section, upward side is positive and right downward is positive. So we have to remember this sign conversions. And same like that, left downward is negative, right upward is negative. Left downward and right upward is negative, left upward and right downward is positive. Okay, for calculation purpose we have to remember all these sign conversions. When it comes to the bending moment, so left side clockwise and right side anti-clockwise is positive, and left side anti-clockwise and right side clockwise is negative. This is sagging bending moment and hogging bending moment. Okay, so in this before knowing that shear force and bending moment, we have to know about types of beams. So there are types of beams are there. First one is simply supported beam. So simply supported beam is nothing but, suppose this is a beam and these two arrow marks are columns. In a building we know that there are several columns and beams. I am taking as an example as two columns and one beam which is simply supported. That is nothing but simply resting on these two columns. This is called simply supported beam. And when it comes to cantilever beam, one end is fixed. Suppose this is a column, okay, and this is a beam. That means this beam is fixed with this column. One end is fixed, another end is free. This is free end. That is called cantilever beam. And next, fixed beam. So fixed beam is nothing but both ends are fixed, A and B. Both ends are fixed. This is a beam and these two are columns, suppose. So both ends are fixed. And next one is overhanging beam. Overhanging beam, nothing but this is one column and this is another column and this is a beam. Okay, so this column, this beam extends up to here, from B to C. So simply supported means up to here the beam is there, but overhanging means this portion is overhanging, hanging. That's why it is called a overhanging beam. And next, both sides overhanging. In this portion only B side it is overhanging, and this portion A side and B side, both side it is overhanging. That's why both sides overhanging. And next, continuous beam. Continuous beam is nothing but more than two supports. Here one support is there, two support is there, and third support. But here there is no support. That's why it is hanging. Here also no support. that's why it is hanging. So here 3 supports are there. More than 2 supports is called continuous beam. And next, types of loading. When it comes to types of loading, different types of loads are there. Concentrated load, this is the concentrated load on a simply supported beam. And next, uniformly distributed load. Suppose this is the column and this is one more column in a building, and this is a beam. On this beam and this column, the slab load will act uniformly. Okay, so then it is a uniformly distributed load, and it is a uniformly varying load. Okay, on the supports on the beam, the load is varying uniformly. So like this, there are different types of loads and different types of beams we have to know before calculating the shear force and bending moment. And I'll explain now in a simple example problem. So this is cantilever beam. Already I told you, one side is fixed and other end is free. So for this we have to draw the shear force and bending moment diagram. So here it is a concentrated load, 1 kilonewton, 2 kilonewton and 3 kilonewtons. So from fixed end to first one is 1 meter, and fixed end to second one is 1.5 meter, and fixed end to third one is total 3.5 meters. So we have to calculate, we have to draw the shear force and bending moment. So first step is, first we have to calculate the support reactions. So in engineering mechanics we learned about equilibrium conditions, that is sigma fx equal to 0, sigma fy equal to 0, sigma m equal to 0. Nothing but sum of all forces in x direction, sum of all forces in y direction, and moment is 0. So here there are no horizontal forces, that is forces in x direction. So x is this one and y is this one. Okay, so but in y direction the forces are there. Sigma fy equal to 0. Okay, but our sign conversion is upward positive and downward negative. This is for equilibrium conditions, not for shear force and bending moment diagram conditions. Okay, don't get confused. And first we have to calculate sigma fy. Forces in all direction is 0, that is this one downward 1 kilonewton, that's why I wrote it as minus. And next minus 2 kilonewtons, that's why I wrote it as downward is negative. And next minus 3, this one. But here RA in fixed end, the support, there are supports are there, reactions are there, that is vertical reaction is there, only vertical reaction is there, so reaction at A in fixed end. But when it comes to simply supported or other ends, there are 3 supports are there, RA, Rx, reaction at x-axis, reaction at y-axis, and reaction at x-axis, and moment. Okay, but here fixed end there is only one reaction, that is upward reaction. Okay, so after that this is upward, that's why it is positive, RA equal to 6 kilonewtons. And next we have to calculate shear force calculation. For cantilever's beam, start shear force calculation for free end, because here it is a fixed end, it is a free end, so automatically the beam will bend like this. So we have to calculate the shear force calculation from free end. So first I am calculating from free end. Shear force at point B. So at point B, exactly at point B, the shear force is 3 kilonewtons. Okay, so here our condition is shear force at point B 3 kilonewtons, positive. Positive is nothing but, here see that our reaction is downward. Our force is downward. Exactly I am taking section here. Why? Because the exactly at the point we can't take the section, that's why I'm taking section here. So section right side downward is positive. This is the red color portion, this is a section, right side downward is positive. Okay, next shear force at point D. So shear force at point D. So point D means nothing but from up to right side of this point D. Okay, so While calculating the shear force, the main principle is from B point to D point, in between there are no forces. Okay, no forces are there, and I mean no loads are there. So the shear force remains constant from B point to this D point. So that's why I'm adding this 3 plus, and this point D shear force is 2 kilonewtons. Then it is positive, and the section is here. Okay, means this is 3 kilonewtons, and from here to here there is no shear force, so the force remains constant up to here, and 2 kilonewtons here, and the section is right side downward, then it is positive. So 3 plus 2, 5 kilonewtons. Next, shear force at point C. So point C, same condition. I'm taking section here. So 3 plus 2 plus 1, 6 kilonewtons. Okay, and next we have to calculate bending moment. For cantilever beams, bending moment at free end is 0, because in free end it moves freely. That's why free end it is 0. I am taking moment at B, that is free end, that is 0. Okay, and moment at D, so moment at D here. So while taking moment at D, moment formula is force into perpendicular distance. So MD, force is here. So this is moment. Force is 3, nothing but this is moving like this. 3 into perpendicular distance is 1 meter. Why? Because we are taking moment at D and we are taking load at B point. So 3 into force perpendicular distance is 1 meter. So 3 into 1. But our sign conversion is, already I told that this is our sign conversion. Right clockwise. So right clockwise is negative. So here this is the right side clockwise is negative in bending moment. So that's why minus 3 into 1. Next, moment at C. So moment at C equal to, this is moment at C. So moment at C is equal to minus 3 from here to here. Minus 3 into perpendicular distance from here to here distance, that is from here to here 1 meter, and from here to here it is 1 meter, and up to here another 0.5 meters. So that's why 1.5 minus 3 into 1.5. And next remaining is this one, D portion. This is also force 2 kilonewtons into this distance. So 2 into minus 2 into 0.5. So I got minus 5.5 into kilonewton meter. And next moment at A, same like that. So moment at A, so 3 into minus 3 into total distance, minus 2 into this distance, and 1 into force into perpendicular distance, 1 into 1. So we got 11.5 kilonewton meter. Okay, for this cantilever beam I have drawn the shear force and bending moment diagram. So this is ultimately our shear force and bending moment diagram. I'll show. So first we have to draw the same diagram which is given in question. After that, below that, first we have to draw the shear force diagram. After that only we have to draw the bending moment diagram. So first I'm taking the value at B. So that is 3 kilonewtons. So 3 kilonewtons, which is positive. Okay, shear force at point B, which is 3 kilonewtons. And I told that from B to D there are no loads, so that's why the shear force remains constant up to here. And next it is 5 kilonewtons. So up to here 3 kilonewtons and 5 kilonewtons is little bit upwards. And next the shear force remains constant up to here, and next 6 kilonewtons and 6 kilonewtons. Okay, and here at A point our reaction is 6 kilonewtons. I'll show that. We calculated the reaction RA at 6 kilonewtons. Why? Because here it is 6 kilonewtons up to, from here to here the shear force remains constant, then definitely it will be 6. If it is not 6 means then your problem is wrong. Okay, you have to verify like that. And next one, this is shear force. Shear force diagram is drawn according to in linear direction. And next, when it comes to bending moment we have to draw the inclined line. So moment at B equal to 0, we know that. And next, minus 3 kilonewtons moment at D. So the D minus 3 downwards. And next, below that 5.5 kilonewtons minus. And next 11.5 kilonewtons. Like that we have drawn this bending moment and shear force diagram. I hope you understood this. In the next video I am going to upload another model problem in shear force and bending moment. Like if suppose these are concentrated loads, in the next problem I will add the UDL, uniformly distributed load. Thank you so much. Thanks for watching.